of all, I'm PowerPoint illiterate, so I'm just going to talk. My first summer institute was 4 years ago, which was also in Asheville, and we brought a team, and they sat us down. We had dinner outside, and then they sat us down to brainstorm, and we had all come with the idea that we wanted to discuss environmental issues from a mathematical standpoint, and we quickly decided on water quality issues. So I was going on sabbatical that year, so I developed this course. And what I decided to do was take data from the neighborhood. We're on the south end of a swamp, which a creek runs through. And so I've talked about this before. There are a lot of unfamiliar faces, which is wonderful. I wasn't expecting that. So what I thought I would do is, rather than sort of give an overview, I would go through as much of the actual course as I can, because unlike some of the other people in the Engaging Mathematics initiative, my course already exists, and I've taught it 3 times. To borrow from West Point, I do feel like I'm still at the crawling stage. The Engaging Mathematics partnership is sort of like the parent who's starting to hold me. I'm starting to take my... So what I would like is, I'm not real good with time, and I don't have a watch, and I don't have a phone. So Cindy, you think 10 minutes is too long, or is that...
5, 10.
If somebody would please, okay, if somebody would please take the responsibility to stop me after 7 minutes, thank you, Lynn, because there are a couple of things that I definitely want to get to, some things that haven't been working as well as I would like, and so I want to talk about what I intend to do about those. So just from the start, I gathered data. We have a local nonprofit called the 9 Mile Creek Watershed District, which has reams and reams and reams and reams of data. They measure, they describe. So I went and I gathered as much data as I could about just different environmental issues for 2 kinds of surface water bodies. There's the creek itself, and then there are 9 to 12 lakes in the watershed. So I wanted to look at both. So first, just to sort of get the students, I wanted to mention who's in the course. The course is called Mathematics for the Liberal Arts. Most colleges or universities have a course like this. The student body are history majors, art majors, English majors. This is a distribution requirement. Very few of these students will ever take another math class in their lives. Most of them don't want to be in this class. You're all used to that, I suspect, many of you. I actually enjoy working with these students because I started my academic career as a creative writing major, so I feel like I can relate to them. So I don't do a lot of lecturing, as little as possible. I don't use a textbook. I wrote most of my own material, and then I have them do some outside reading from actual publications from the district itself. And the first piece of writing, they run into sigma notation almost right away, and I don't warn them about that. And most of them have never seen it before. And then we talk about it in class. Oh, here's a piece of quantitative literacy that this publication is assuming their readers understand. So maybe if you want to be able to go out there and understand the world around you, you might start thinking about that, being aware that there are these things that and this is not high for scientists and mathematicians. So I got a little off track there. So I start with I don't even start with any equations or any algebra. I start with a ranking system. There's a water quality for moving surface water, streams and rivers. There's a water quality, environmental quality ranking system, which is A through E. I'm not going to get the terminology exactly right, but A is pristine, and then it goes down to E is nothing can live here, and then it grades down from there. And in order to sort of take averages and to do graphs, we have to turn that into a numerical scale. So that's the first introduction. It's very simple. It's just a quantitative scale. Nominal scale, is that what the statisticians call it? And we turn it into a quantitative scale. Now I need to look at my notes because I forgot what I was going to say. Oh, okay, so yeah. So this this categorization is called ecological use. That's the terminology that's in the literature. So we start talking about ecological use. And there are three kinds of ecological use. There is existing, there is historical, and there is potential. And all of those are ranked on the same 5-point scale, but they're arrived at using different sorts of computations. And so we go through the different sorts of computations based on actual field observations. And that's where the sigma notation comes in. The existing ecological use is a weighted sum of observed organisms in the body of water. So we start with that, and I have them do some weighted sums. I don't have them, we do field trips sometimes when we have the equipment and when we have the time and when the weather permits. I do not have them actually go out and stick the electroshock in the water and have the little stunned fishies float to the top, which is how they measure what's living in the water. The DNR professionals do that. I don't have the students do that. So we talk about just water quality using these quantitative measures. This is sort of a gentle introduction to how mathematics is relevant to studying environmental quality. Historical ecological use is just an ordinary mean in the usual sense, the ordinary mean of the existing ecological uses over a specific period of time. And so we do some graphing, and I have them tell me about trends that they see, changes in it. Is it getting better? Is it getting worse? What can you see? Was it getting better for a while and then started getting worse again? I talk about some changes that the district has made in the structure and the physical infrastructure of the creek, and see if they can spot in the graph when those changes took place, and most of them can. And then we talk about potential ecological use, which is a measure of what environmental science thinks ought to be able to live there in ideal circumstances. And that takes in all sorts of circumstances. Water temperature, creek flow, creek discharge, pH, and then external to the actual body of water itself, it takes into account things like how much impermeable surface is surrounding it. That means parking lots, streets, sidewalks, things like that. Whether the bank is natural with shrubs and weeds and things like that, or whether it's been mown lawn right up to the edge of the water. And that's where I tried 2 of the 3 times I've taught the course. We actually had a field trip, and we had the students go to a park that the creek flows through. And I assigned teams to go, and I tell them, don't worry about getting it right or wrong. None of us are environmental scientists, myself included. Just give it your best, talk about it with your team, decide what you think, and then jot it down, and then we'll go home and do our own potential ecological use. And don't worry, I don't even tell them what the district rates it as, because I don't want them to worry about being wrong. I just want them to think through the process and then do the calculations. Okay, so then we move from there. Then we start talking about some actual modeling. The main mathematical topics that I get to are modeling, which includes things like 7. Oh dear. Oh dear, oh dear, oh dear, oh dear. Okay, so we do modeling, which includes linear regression, other kinds of regression. We do correlation coefficients, we do positive, negative relationships, we talk about slopes and their interpretations as multipliers. We talk about good fit, bad fit. We talk about the difference between absolute error and relative error. And then we look at some data having to do with nitrogen concentration, phosphorus concentration. It is a suburban area, which means there are lots of nicely manicured lawns and golf courses, which means there's lots of fertilizer being put on the ground, which means that as the suburbs spread out, we're seeing more and more lakes that are choked with algae, which is sort of a drag. And so we study that. We look at the data having to do with, in particular, the one I wanted to talk about that I'm not completely happy with is we correlate monthly rainfall with increase or decrease in nitrogen concentration. And the research question there is there evidence that excess nitrogen is being washed into this one particular lake. We only do one lake right now. Turns out the correlation is fairly strongly negative. So what we're seeing is that when there's heavier rain, the nitrogen concentration actually seems to go down. So that would seem to suggest that maybe the answer is no. Maybe external nitrogen is not a particular problem. And what I'm going to do this fall that I haven't done before, and I just thought of this last night, so even if I had a PowerPoint, I would have to change it. What I'm going to do is I'm going to look at some other lakes. As I say, there are 9 to 12 lakes. This particular lake, I'm pretty sure, is actually in the middle of a public park. So maybe there's not a lot of fertilizer being applied to the lawns. So I'm going to look for a lake that's maybe abutting a golf course and see if we can see any differences. Any of you who are environmental scientists or hydrologists, I would very much like to talk to you before the Institute is over, because as we've heard in the opening sessions, many of us, myself included, are way outside of our comfort zones in doing this. I was trained as a mathematical logician, so this is not what I'm used to. The other thing I wanted to talk about is the last topic in the course is some estimation, and we're talking about, I know I'm out of time, but just, we talk about the correlation between impermeable surfaces, again the parking lots and the streets, versus the frequency and severity of flooding events. And so we do some calculations on impermeable areas surrounding the creek, and how much, so we do some estimation of how much the creek could carry in terms of flow before it overflows its banks. And I came up with an iterative model, which on reflection is basically, it's a discrete difference equation. I don't tell them that. And it has the creek with a relatively moderate rainflow. It has the creek overflowing within 15 minutes, and I know that's not right. So I need to work on that. It needs to be logistic, not exponential. So I need to fix that. That's what I do.